Hello everyone. In this video I'll be reviewing how to solve a more complex trigonometric function, this one with a modified argument, still over the interval 0 to 2 pi, so as opposed to a question where I say find all solutions. So I have a specific interval, and this is what I refer to as a modified domain, or excuse me, a modified argument, meaning that in here the argument of the trig function has been modified. Either something's been added or subtracted to my theta, or whatever the variable is, or something's been multiplied to the variable, or theta in this case. Solving these require more steps than a problem that does not have a modified argument, because of such, we have to consider a wide range of possibilities. We'll start though by approaching this as if it were tangent of, I'll just say x equals 1. So I'm substituting for the argument theta plus 3 pi over 2. I'm saying let's assume that it's tangent of x equals 1. If that were the case, I need to identify tangent of what angle or what radian measure gives me a positive 1. For that I need to refer to either my 30, 60, 90 or my 45, 45 right triangles. And of the two of them, my 45, 45 right is going to be most appropriate, because I could take tangent of 45 degrees and get 1 over 1. So 1. This means that I'm using the radian measure of pi over 4. Now, since I'm talking about tangent being positive, I have to consider that I'm in either the first or the third quadrant, so I have to consider all possibilities, meaning that in quadrant 1, I have, of course, pi over 4. Its equivalent in quadrant 3 will be, using reference angles, will be 5 pi over 4. So these are the two angles that I have to consider. Now normally, if I didn't have a modified argument, I could stop here and say these are my answers. Because of my modified argument, I have to examine what is the effect of adding 3 pi over 2 to my angles. So because tangent of x equals pi over 4 and 5 pi over 4, I'm going to say, when I modify my x, how will that affect each of these values? In other words, I'll have these two equations. Instead of x, which is what this expression was, I've now put back in theta plus 3 pi over 2, and then the same thing down here. Originally it was x, now say theta plus 3 pi over 2 equals both pi over 4 and 5 pi over 4, and I have to include my pi over k. Excuse me, my pi k. Now, even though I have a specified domain, I'm including the pi k because I need a way to ensure I cover all possible angles. In other words, if I do a few rotations in the positive direction, if I do a few rotations in the negative direction, I need the plus pi k, and again the pi is from the period of tangent, added on to each of the solutions that I found first. So this is how I account for my modified argument. And in each one of these, what I will do is solve for theta. So I'm going to solve for theta as if it were a regular variable. So in each case, I'll subtract 3 pi over 2 from each side. Now, because I'm subtracting, I want a common denominator. Since my common denominator will be 4, I'll multiply each by 2, and I'll actually be subtracting 6 pi over 4 from each of these values. So, when I subtract pi over 4 minus 6 pi over 4, I'm left with negative 5 pi over 4 plus, still plus my pi k. When I subtract 5 pi over 4, minus 6 pi over 4. I'll get negative pi over 4 plus pi k. So right now, I've seen that by modifying my argument, now I'm looking at negative 5 pi over 4 and pi over 4 as possible initial solutions. Now obviously those won't work, neither one is in my domain, but I need to see if I were to go a few more revolutions, would I get an answer, an iteration of those values that would be in my domain. To do that, I'm going to take the values of negative 1, 0, 1, and 2 and substitute them in for k, and then see what I come up with. So for example, I'll start with negative 5 pi over 4 plus pi k. So for my values, negative 1, 0, 1, and 2, and those are always the values that you'll use, they ensure that you have at least one revolution in each direction, or one period, I should say, in each direction to account for. In other words, helps us cover all possibilities. For each one of these, I'll put in k is negative 1, I'll put in for the k here, so it gives me a negative pi. When I want to add that to negative 5 pi over 4, I need a common denominator. Currently it's 1, so I'll actually be making this a negative 4 pi over 4. That's actually what I'll be adding to all of these, in each one of these cases. So my first case, negative 5 pi over 4 minus 4 pi over 4 is where I get negative 9 pi over 4. What that means is that is going to be an actual solution to this original equation. Same with the rest of them. When k is 0, of course I have 0 pi. And negative 5 pi over 4 plus 0 pi is just plus 0, so it stays negative 5 pi over 4. When k is 1, now I have a positive pi, positive 1 pi. So now I'll be adding still 4 pi over 4. Negative 5 plus 4 gives me a negative 1 pi over 4. And 2 pi becomes 8 pi over 4, and when I add that to negative 5 is where I get positive 3 pi over 4. So what we're saying is for this value, we have these 4 possible solutions. And I want to do the same with negative pi over 4 plus pi k. Do the same thing. So when k is negative 1, it's negative pi, which again is negative 4 pi over 4. When I combine those, I get negative 5 pi over 4. When k is 0, that should be, negative pi over 4. When k is positive 1, that gives me pi, or again a positive 4 pi over 4, which when I add will give me a positive 3 pi over 4, and then with 2 pi again becomes 8 pi over 4, and I add to get 7 pi over 4. So I have 8 possible solutions. I only want the ones that are in my original domain, between 0 and 2 pi. So that means that's only going to be 3 pi over 4 and 7 pi over 4. Now even though 3 pi over 4 appeared in both sets of solutions, I only need to include it once. All answers are going to be 3 pi over 4 and 7 pi over 4. Now as you do some of these, you'll be able to mentally eliminate some of them. For example, this first one we did with negative 5 pi over 4 and negative pi, you should be able to reason through eventually that that will be out of our range because we want it to be positive between 0 and 2 pi. So even though this is a lengthy process, the more you do it, the more you can mentally eliminate some possible answers to speed up the process. But again, first we substitute it for the modified argument, solve for the new equation. I got pi over 4 and 5 pi over 4. Substitute it back in for the argument, solve for theta. I got these two possibilities, and then I substituted k for k, -1 through 2, for each one, and then of those possibilities, in this case there were 8, I picked which ones are in the domain that I wanted. And that's how I ended with my solutions of 3 pi over 4 and 7 pi over 4.